Good morning, geometry class. Hope everybody had a great night last night, and we're just getting ready to get started this morning. So what we're going to do is open in prayer, and then we're going to check our homework. Our homework that was due at 3 o'clock today. Some of you did not make that deadline, so you need to make sure you're more proficient and diligent in getting your homework in. So the homework we're going to score is from pages 5 and 6. That's from last week before our spring break. Today you have to take your checkup, so that's pages 14 and 15. And so for the checkup, you're going to need to do 1 through 8 on the checkup, and you're going to have to do 9 through 24. You're going to do the odd numbers, so 9 through 24 odds, okay? So 1 through 8, and then 9 through 24 odds. You're not allowed to look back, so be sure your parents sign off on the checkup. Make sure they put the time you start, the time you finish. Again, all formulas are to be done by memory, so be sure that you're memorizing your formulas. So you're going to take the first 15 minutes of your class, 20 minutes of your class time. I want you to take the checkup, and then you can hit pause, and then we're going to actually teach pages 16 through 18. So make sure you get that in. The checkup is due by 3 o'clock today. 3 o'clock today. The homework that I issue will be due by 3 o'clock tomorrow. So understand, make sure you get your homework in and your checkup in on time, okay? We're going to quickly pray. Then we're going to do just a quick review. I'll go over our homework, and then we'll go on to pages 16, 17, and 18. So let's ask God's help. Dear Jesus, help us now. We need your help. Give me, as the teacher, wisdom. The students, wisdom as well. Wisdom is the application of knowledge. So help us to apply these principles, these theorems, these rules that we've learned in geometry. I ask that you would illuminate the students. I pray they work hard and diligently. Bring to remembrance as they take their quiz everything that they've learned and studied and prepared for. Well, thank you and praise you in Jesus' name. Amen. All right, so quickly, by way of review, so far we're learning these formulas. We're learning how to find the perimeter of a polygon, the area of polygons as well. So the first thing we looked at was the perimeter of a rectangle. The perimeter of a rectangle is P equals 2 times the length plus 2 times the width. And the perimeter of a square is P equals 4S. Then the area of a rectangle, which is, remember, let's not forget, the area of a parallelogram and the area of a rectangle are the same. That is area equals base times height. And then the area of a square is area equals S squared. Then we looked at the area of a triangle is 1/2 times the base times the height. And we have a special case. If we have an equilateral triangle, the formula is area equals S squared times the square root of 3 over 4. Again, these must be memorized. You cannot look back on your quiz. Be sure that you memorize those before you take the quiz. Now, we're going to quickly score page 5 and 6. And we had to do the evens on 5 and 6, so we're quickly going to give you the answers. And then there were a couple problems that some of the students had questions on. We're going to try to do those together, make sure everybody is on the same page. So quickly, for the evens, number 5, all right, so page 5, number 6, we're going to give you the answer, 16 meters squared. Number 8 is 22.2 meters squared. Number 10 is 115 millimeters squared. Number 12, which we will do this one together, number 12 is 24. Side B is 24 meters. 24 meters. Number 14 is 27.71 millimeters squared. Number 16 is 27 meters. And then number 18 is 6 centimeters. And then number 20 is 40 millimeters squared. So now that you have those answers, make sure you check your work, see if you've got them right. We're going to look at a couple problems that some of the students had a question on. Look at problem number 12. The ratio of the width of a tennis court to its length is 5 to 12. If the area is 240 meters squared, what is the length of the tennis court? So we have the length is 5 to 12, so the length to the width. So area, we know, of a rectangle is base times height. We know the area is given to us, it's 240 meters squared. And then we have the base times the height. So the base would be 12x. So I'm just going to put here 12, we'll put the units first, millimeters, x times 5 millimeters x, okay? Simply, we're going to multiply, so 12 times All right, so 12 times 5 is 60. All right, so we're going to go millimeters squared x squared. Okay. Now we just got to get obviously we want to get the variable by itself, the variable x. So we're going to divide both sides by 60 millimeters squared. Okay. After we do that, we simply cancel out our units here. So x squared is equal to, and then 24 divided by 6 is simply 4 millimeters squared. Okay, now how do we get rid of the exponent here, class? All right, we want to simply find the square root of both sides. So x is equal to 2 millimeters. Now that's not the final answer. We got to go back to the original problem. The ratio from width to length is 5 to 12. So the width would be 5x. So 5 times 2, which would be 10 millimeters. And the length would be 12 times 2. And that's what we're kind of looking for. The question is, what is the length of the tennis court? So 12 times 2 would be 24 millimeters there. Okay, so that's for number 12. Look at number 14. Okay, number 14 gives us a special hint. So now what I often do is as I do these story problems is I try to draw the shape to give me an idea, give me a visual of where I'm going and how I'm doing this. So a diagonal of a rectangle is 8 millimeters and forms with one side of an angle measuring 30. So, okay, so simply draw a rectangle. It's got a diagonal. We know the diagonal is 8 millimeters, right? Real simple. Now, we know that the diagonal forms with one side a 30-degree angle. So we know we got the other side would be a 60-degree angle, right? And then we have a 90-degree angle here. So, since it's a rectangle, what's the definition of a rectangle? Going back a few paces, a definition of a rectangle is a parallelogram with 4 right angles. Okay, so we have here a right triangle. Now this is a special case because in our hint it says, find the area of a rectangle. Hint, the diagonal creates a 30-60 right triangle. Now, what do we need to do here? So we have 3 sides. If this is a right triangle, class, okay, what is that line called that's opposite of the right angle? The hypotenuse, correct. So if we have the hypotenuse, I need to find the length of these 2 sides. If I can find the length of these 2 sides, we could simply find the area, which is base times height. Now, how do I find the length of 2 sides? By using the 30-60 right triangle. So that's the last pace 11, 17. This is why we need to memorize certain rules and certain principles because they keep coming back. So we see here the 30-60 right triangle. To find the hypotenuse, we have C equals 2A. And to find the length of one side, we have B equals A times the square root of 3. Now, all we need to do, if this is the hypotenuse, remember the hypotenuse is always represented by what letter? C, correct. So, I'm going to plug it into my equations here. So, 8 millimeters equals 2A. Okay, we're finding A here. So, we divide both sides by 2. So, A equals 4 millimeters. That's what A equals, 4 millimeters. All right, so let's call this side A, 4 millimeters. Now we got to find side B. So B is simply A times the square root of 3. So if A is 4, B equals 4 to the square root of 3. So I'm going to put that on my triangle. Now that I have the length of both sides, I have the length and the width. Now I want to just simply plug it into my equation and then multiply. So area equals base times height. So 4 to the square root of 3 times 4. Let me write our units in here. So 4 to the square root of 3 millimeters. All right, times 4 millimeters. Okay, I hope you can see that clearly. I hope you like my pink marker tonight. All right, so we can multiply our numbers there, our whole numbers. So 4 times 4 is 16 to the square root of 3. Oh, yeah, square root of 3 millimeters squared. Now, in this case, you want to get rid of the radical sign. So you want to remove the radical sign and just simply hit the square root of 3, then multiply that by 16. And that should give you an answer of 27.71 millimeters squared. So remember, when we talk about geometry, one pace is not isolated from the next. Everything we're learning, we're building and building and building. So it's important to know how to find the length of a side of a right triangle, Pythagorean Theorem, the 30-60 right triangle theorem, and also the isosceles right triangle theorem as well. All right, so let's erase this. Be sure to copy your work. It's also because you'll see problems like this, and it'll kind of give you a hand. All right, look at number 20. Number 20, okay? Some of the students had questions about number 20, so let's do that one together. A rectangle whose base is twice its altitude is inscribed in a circle. So does anyone remember what inscribed means? Inscribed. Very good. A rectangle in a circle. Okay, so, okay, a rectangle in a circle, and we have here a rectangle whose base is twice its altitude. All right, do we know what the altitude is, class? We do not, so we will denote that by A. And we see the base is 2 times the altitude, twice the altitude. We're going to call this side, this would be side B, right? The base. So base would be 2 times the altitude. Now, find the area of a rectangle. Find the area of a rectangle. So, again, area equals base times height. Now, let's look at this again. This rectangle whose base is twice its altitude is inscribed in a circle whose radius is 5 millimeters. Whose radius is 5. So, if this is the center of the circle, we know that radius is 5 centimeters. Okay? Now, what we need to do here is simply remember that that radius not only is 5 centimeters, but what is the diameter? Because that gives us the whole diagonal, right? So remember, the diameter is 2 times the radius, so the diameter would simply be 10 centimeters. Okay, now, all right, we have a right triangle that's formed here. We have a diagonal, so we have a right triangle. So let me put the A here. All right, so we have the hypotenuse. How do I find the length of a side? Pythagorean Theorem. So C squared equals A squared plus B squared. So C squared is the hypotenuse, so 10 centimeters squared is equal to, all right, A. So we're going to put A squared plus, and what's B? So we're going to say B would be 2A squared. All right, that represents side B. Let's simply multiply. We have 100 centimeters squared is equal to A squared plus 4A squared. Okay, combine like terms, so 5A squared is equal to 100 centimeters squared. We've got to get A squared by itself, so divide both sides by 5. A squared equals, and then 100 divided by 5 is, real simple, 20 centimeters squared. That's not the final answer. Quickly, we want to find the square root of both sides. So A equals, and then simply you want to get your calculator out and find the square root of 20. So the square root of 20 is 2 to the square root of 5. So, okay, 2 to the square root of 5, and then you can simplify that even further. But we're going to take that, I'm going to keep it that way, and I'm going to just show you quickly what to do if we have a radical sign in our answer. So now, let's go back to our base and our height, okay? So, okay, so we have A is 2 to the square root of 5. B is 2 times A. So 2 times 2 to the square root of 5, which is simply the B, 4 to the square root of 5. So there's my width and height. So let's plug it in our equation here. 2 times this, well, 4 times the square root of 5 times 2 to the square root of 5. We're going to multiply. So what we have here is 4 times 2 is 8. 5 times 5 is the square root of 25. The square root of 25 is 5. And 8 times 5 is 40. So the area of this rectangle for number 20 is 40 centimeters squared. So put 40 centimeters squared. Oh, it's not centimeters. 40 millimeters squared. So make sure you copy that work down. Okay, I'll leave it on there for a few seconds, and then that will cover your homework from last week, from before our spring break. Now, I want you to turn your textbooks, after you get that copy down, I want you to get your textbooks and turn to page number 16. Page 16. Okay? Now we're going to see the area of a trapezoid. The area of a trapezoid. Okay, so now that you have that copy down, I'm going to erase this. Okay, the area of a trapezoid. Theorem 101. So now that we're talking about a trapezoid here, so I don't remember the definition of a trapezoid. The definition of a trapezoid is trapezoid has only one pair of opposite sides parallel. One pair of opposite sides parallel. So that would be the top here, and the bottom would be the parallel sides. I want you to notice the very first paragraph. Any side can be the base of a parallelogram or a triangle. But in a trapezoid, both parallel sides, so the top and the bottom here, both parallel sides are the bases. So now since we have two bases, we have base 1 and base 2. Okay? Base 1 and base 2. Now, the altitude of a trapezoid is the perpendicular from a base to the opposite base or the opposite extent. So, okay? So from one base to the next, we have our altitude. Okay? So we can go from here to here. We can go from here to here. And we can go from here to here. Or to there. So from the base to the opposite base, we have the altitude, okay? Now the altitude will be the same length. The altitude never changes. The altitude is the same length. Now, I want to draw your attention here to that second illustration in your book. So that second illustration here, so I'm just going to simply draw, okay? All right, we have A, B, C, D. Okay, if we draw a diagonal from A to C, okay, we draw a diagonal from A to C, all right, now we divide the trapezoid into two triangles. See the connection? We have two triangles. So, if I can find the area of both triangles, I can add those areas up and simply find the area of the trapezoid. So do you remember what the area of a triangle is? We have two triangles now. So the area of a triangle, very good. Area equals 1/2 the base times the height. Now since we have two triangles here, we want to take the sum of the areas of those two triangles and add them together. So we would go 1/2 times the base times the height, right? Plus 1/2 times the base times the height. Now, there's an easier way to simplify this and write this, which brings us to Theorem 101. Theorem 101. So all we're going to do is we're going to simplify this to area equals 1/2 times the altitude or the height times the sum of the bases. Times the sum of the bases. So this is the, highlight this, so page 16, Theorem 101, I'm going to highlight this formula. This is the area of a trapezoid, the area of a trapezoid. So let's look at page 17, okay? We'll kind of practice a couple of these together on page 17. Let's look at number 4, right? We'll do the evens, okay? And then the odds on page 4, 17 and 18, you will do the odds for homework today, okay? Again, that'll have to turn in tomorrow at 3 o'clock. So let's do a couple of these, all right? So I'm just going to write the formula up above here. So the area of a trapezoid is 1/2 times the height times the sum of the bases, okay? So let's practice. Look at number 4 on page number 17. Page 4 on number 17. All right, find the area, all right? Okay, if we have the bases are 7.5 meters, 8 meters, and the altitude is 6 meters. So let's plug and chug. So 1/2 times the altitude, which is 6 meters, all right, times the sum of the bases. So 7.5 meters plus 8 meters. Okay, make sure you write everything out neatly. Keep everything neat, all right? So simply here, okay, let's go 7.5 plus 8, which is simply 15.5. So 1/2 times 6 meters times 15.5 meters, okay? One of the things I like to do is sometimes I just like to eliminate the fraction early if I can. We know 1/2 and 6 will cancel each other out. So 1/2, right, goes into 6 3 times. So 3 meters times 15.5 meters. So 3 times 15.5 is, get your calculator out, is 46.5 meters squared. And again, since we're looking for the altitude, be sure that your answer is in square units. All right, let's look at number 6. I'll leave that on the board. You can copy that down. Look at number 6, okay? So again, area equals 1/2 times the height times the sum of the bases. Okay? Area equals 1/2. Now, what is the altitude for number 6? We have 3 centimeters. And then we have our bases are 4.5 centimeters plus 5 centimeters. All right? So, okay? 4.5 centimeters plus 5 centimeters is simply 9.5 centimeters. Okay? Now, again, you could do this early. You could change this to a decimal if you like. 1.5 or 0.5, excuse me, times 3 times 9. I'm just going to take one more step further. We're going to go 3 centimeters times 9.5 centimeters, which gives me 28.5 centimeters squared. And then get your calculator out and do 0.5 times 28.5, which gives me an answer of 14.25 centimeters squared. 14.25 centimeters squared. So real basic, real simple there, right? Let's do a couple story problems. So let's look at number 8 and number 10 on page number 18, and then we'll close class for today. Okay, so I'm going to erase these out. Okay, number 8. The bases of a trapezoid are 17 meters and 18 meters, and its area is 120 meters squared. Find the altitude. So area is 120 meters squared equals, all right, 1/2 times the height times the base, the sum of the bases. So 17 meters plus 18 meters, okay? 17 meters plus 18 meters. Now, we want to solve for h. I want to get h by itself. So let's begin to simplify. Always we do our parentheses first here, so I'm going to go a little longhand just so you can see every step. Okay, 17 plus 18 is 35 meters. Very good. Okay, so I'm going to bring it down here again. 120 meters squared equals 1/2. All right, so let's get our calculator out. So 1/2 of 35 would simply be 17.5, we're going to put here meters H. Okay, 17.5 meters H here. And then now what we're going to do is got to get H by itself, correct, class? So divide both sides by 17.5 meters H. Okay, find the height. Get your calculator out. 120 divided by 17.5 is 6.86. And our units, I have 2 units up here, I have 1 down here. So we're going to cross out one of those units. I'm just left with 6.86 meters. That's the height. All right, let's do one more. Let's look at number 10. Number 10. All right, I'll leave that there for you just for a second here. Copy that down. Number 10. Okay. All right, we'll close with this one here. Okay, an isosceles trapezoid whose legs are each 5 centimeters in length has an upper base of 8 centimeters and a lower base of 16. So let's draw this. Okay, we have a isosceles trapezoid. Remember, what's the definition of isosceles? It has 2 equal sides, correct? So we have, all right, whose legs are 5 centimeters in length, and whose upper base is 8 centimeters, and lower base is 16 centimeters. Find its area. Find its area. So now, hint. Let's look at the hint. 2 triangles are formed on both ends of the trapezoid. The length of the hypotenuse is 5 centimeters, and the length of one leg is 4 centimeters. Use the Pythagorean Theorem to determine the altitude. Okay, here's the formula here. We have the height. We have the 2 bases, right? 2 bases here. Now we need to do the altitude. So we have 2 triangles formed here. So we're going to draw 2 triangles formed, okay? That's what it says, right? We have 2 triangles formed there. Okay, now, we know the length of the hypotenuse is 5. So if we have remember, the altitude is always a perpendicular. This forms a right triangle here. Okay, we got the hypotenuse, and we have to one side. We got to find the altitude. Once I find the altitude, I can plug it into my equation and solve for the area. So now, again, if it's a right triangle, how do I find the length of a third side? It's given to us in the hint, the Pythagorean Theorem. So, c squared equals a squared plus b squared. Okay, remember, this is the hypotenuse. It's the opposite of the right angle. So 5 centimeters squared is equal to, all right, a squared plus b squared. So we'll go 4 centimeters squared plus b squared. So 25 centimeters squared is equal to 16 centimeters squared plus b squared. Now, class, how do I get b by itself? We got to apply, very good. We've applied the subtraction axiom of equality here. So we're going to subtract 16 from centimeters from both sides. So b squared is left by itself, and then 25 minus 16 is simply, 25 minus 16 is, 9 centimeters squared. Let's find the square root of both sides. So b equals 3 centimeters. Now, what's the altitude? 3 centimeters. Once I have my information, now let's plug it in. Area equals 1/2 times 3 centimeters times the sum of the bases. So 8 centimeters plus 16 centimeters. 1/2. Okay, 8 plus 16 would be 24 centimeters. Okay, all right, now 3 times 24 will give me, 3 times 24 will give me what? 72 centimeters squared. And then 1/2 of 72 centimeters squared will give me 36 centimeters squared. So, taking what we've learned from the previous book, how to find the sides of a right triangle. And applying here to our trapezoid, we're able to find the altitude and able to find the area. Well, that'll conclude our class for this morning. I pray you guys do well in your quizzes. Make sure your quizzes are due 3 o'clock today, and then your homework will be due 3 o'clock tomorrow. Have a blessed and safe day. I'll be praying for you guys and girls. Good day.